Hello and welcome to Mr. Float. In the previous video, we saw how to define your own class. We saw how to define an init function which has the attributes of an object such as name and age. We saw how to define a method inside a class. We created an object and we also called a method on that object. And we saw that everything was working fine. If you haven't watched the previous video, there is a link right here. You can go ahead and watch it and then return back to this particular video. Today we are going to talk about the 4 pillars of object-oriented programming, or also known as the 4 fundamental principles of object-oriented programming language, namely inheritance, encapsulation, abstraction, and polymorphism. Let's start with my favorite, inheritance. The word inheritance is self-explanatory. Keeping it simple, a child inherits many things from their parents. The most important of them all is DNA. In the same way, in classes, a child class can inherit the DNA or the attributes from the parent class, but we have full control of what to inherit from the parent class and what not to inherit from the parent's class. I bet you're thinking we should have this option in real life. Petty jokes. Let's see how to implement that and build on this example that we have of class dog over here. Let's name our parent class animal class and parent class, and let's call the dog class child class. Now if you notice, in the animal class and the self class, we also have the same attributes over here, but the entire point of coding is to not repeat a code or to have low redundancy. In the same way, we don't want the same attributes to redefined inside the class dog. So what we do is we remove this and we can just add animal over here. This is a child class and which is inheriting the attributes from the animal class. In my case, we are inheriting all the attributes from the animal class. Now, this method over here is defined inside the dog class. And similarly, like before, all we have to do is we have to create an object and we call the dog object over here, and we pass in the 2 attributes, Tom and the age, which is the name and age. But if you notice over here, there is no name and age inside the dog class. However, since it inherits the properties from animal class, the attributes are already defined in the animal class. So this name and age should work absolutely fine. And if you see, we have no errors over here. Now, if we go ahead and call the method speak on dog, it should still work fine. It is saying Tom is saying woof woof. So this is what inheritance is all about. Now I want you to pay real attention to this one. This is also called as superclass, and this is also called as subclass. Let's just say you want to create another class called cat, which inherits its attributes from animal. Now over here in the cat class, I want my cat to have the attributes of name and age, but also I want it to have the attribute of color. But in the animal class, we only have name and age. How do we go about this? In this case, all we need to do is define the init again, and we need to type in the attributes that we need. In my case, in the case of class, we need name, age, and color. Now redefining name and age will be repeating the code, which is what we are trying to avoid in this first place. So all we need to do is type in super. This is a built-in function which simply means that get these attributes from the superclass. In our case, it is animal. So from superclass, we want init and we want name, comma, age, right? So we want name and age from the superclass. However, we want to define color only in the cat class. So in that case, all we need to do is self.color is equal to color. So what happens now is, let me show you. So let's remove the dog from here and let's say C1 is equal to cat whose name is Spots, who is 4 years old and is brown in color. Now you see it worked totally fine. It got the name and age from the animal class and the color brown was assigned in this particular class. Now let's just say we want to define speak over here as well. I'm just being lazy and copying it right now. Is saying meow. So now if we go ahead and say c1.speak, it should say Spots is saying meow, right? So you see it totally works fine. I hope you have a clear understanding of what is inheritance. You can go on adding many animals to this list of dog and cat, such as horse, donkey or monkey, and then inherit from the animal class and define just that one specific attribute that you need inside that specific class. You can inherit from multiple classes. So for instance, I can have dog and animal, and you can build a separate class for Labrador, and you can inherit from animal as well as dog. Okay, let's move on to the next principle, which is encapsulation. The word encapsulation literally means the action of enclosing something, just like a capsule. In the same way, when it comes to our program, you see, when you create a class animal, you define the attributes, you define the methods, you define the subclass as well, everything inside one particular class. The same principle applies to our animal class. The attributes of that class, the methods of that class, and the objects of that class are encapsulated in one class, which is called as animal. So everything is inside the class itself. So that itself is called encapsulation. Only classes or object-oriented programming provide the feature of encapsulation. Now let's move on to the third important principle, which is known as abstraction. To understand abstraction, let's go back in time to a summer afternoon when you were a 2-year-old kid. You were feeling hot and you wanted to turn on the fan. All you knew was there was a button. When pressed, the fan would turn on. But you had no clue what is going on behind. You had no clue about the electricity. You did not know what a motor is and the electrical circuit that goes on in the background. So you just knew the switch and the action, that is the fan turning on. In the same way, with programming, I can go ahead and give you this example. If you go ahead and just type in print and pass it a string such as hey, you know it is going to print out the word or the string hey, but you do not know how the print statement is built. In the same way, when it comes to classes, I'll open a new file over here. If you notice, this particular file is named as animal, right? Let's go to a new Python file and let's import dog from animal. You see there are no errors over here. Now let's go ahead and print R1 is equal to dog, whose name is Rocky, and age is 6-year-old. And we'll just call the method speak on this particular dog. Now, you see it is working totally fine. But for a new user who has no clue of this particular file, but the file is made public, right? He just knows that if name and age is passed on to this particular class, and when you call this method, it is going to say woof woof. So this itself is the property of abstraction. A new user or a person does not need to know what is going on in the background. Now let's talk about the last fundamental principle known as polymorphism. Let's go back to our main file over here. The word polymorphism means many forms in one. We can take water as an example. Water can exist in 3 different states: liquid, ice, and steam. In the same way, when it comes to classes, it can also have many forms. For example, let's just say we define a function speak in the parent class. And we say print animal is speaking. Now, if you notice one thing, animal has a method speak, dog has a method speak, and cat also has a method speak. Now let's go ahead and create an object d1 of the class dog. Let's just call him Rocky with the age of 8, and let's call the method speak on the dog. You see, it is saying Rocky is saying woof woof, but I want you to pay real attention to this one. Now in both these classes, there is a common method called speak. It is existing in animal class and it also exists in the dog class. But when you call d1 speak, it doesn't go to the animal class, it goes to the dog class because the dog class has the most priority over here. For instance, if this method would not exist, and if I could just pass this here, now if we run it, it would say animal is speaking. Now this dog class, when called this method speak, it goes to the animal and fetches speak. I'll explain what is happening over here. First it goes to the dog class and sees if there is any method called speak. If it does not find the method speak inside the dog class, it goes to its parents class, which is the animal class. And here when it found the method speak, it fetched that and then it printed animal is speaking. This is what is known as polymorphism. One method which exists in different classes but has a different priority level. It is as simple as that. With this, I conclude today's video, and in the next video, we'll learn about special methods inside classes. So stay tuned. If you really enjoyed the video, please hit the like button and subscribe to my channel. It keeps me motivated to go ahead and create more such videos for you. Thank you.